Hello, good evening, everyone. Now we are going to discuss another example about titration and dilution. So if you see over here, in this case, we combine the data of titration and dilution. So if you see, there are also several code that is inserted, or it means that it is referred to the type of substance that we use. So for example, 20 milliliter of sulfuric acid, 1 molar, be careful, that is the one that we call as Fa1. And then after it's diluted into 100 milliliter, then the diluted solution is Fa2. So actually, we can say Fa1 Fa1 is the concentrate, the sulfuric acid before dilution, or we can say Fa2. I'll just write down over here. So it means Fa2 is actually the Fa1, which is sulfuric acid, which is diluted 10 times. Oh, sorry, 10, not 10 times, 5 times. How do I know 5 times? Because from 20 milliliter to become 100 milliliter. So it's diluted 5 times. Okay, and then after that, next, meanwhile, NaOH or sodium hydroxide 2 molar, Fa3. Okay, so this one is what we call as Fa3, is diluted 10 times. And the diluted solution is identified as Fa4. So it means that Fa4 is actually Fa3, which is NaOH or sodium hydroxide, that is diluted 10 times. Now we have to know this for sure so that we won't get mixed up later for the titration, because over here, then take a look over here. After that, 25 milliliter of Fa2, which means that sulfuric acid, diluted one, is titrated with some amount of Fa4, which means that the sodium hydroxide, the diluted one, in centimeter cube unit. Okay, yeah. So take a look, yeah. Now, and then the answer of this question will be found step by step. So the first step is answering part A. What is the concentration of Fa2? So it means that we can say, because now we have the code, so we can just say the molarity of Fa1 times the volume of Fa1 equals to molarity of Fa2 times the volume of Fa2. Yep, okay. And then here we have 20 milliliter for the volume of Fa2. Meanwhile, for the molarity, we have 1. I'll just put here 1 times, be careful here, I change it, I convert it into decimeter cube. So it means I convert it into 2 times 10 to the power of minus 2 decimeter cube, yeah, equals to the molarity of Fa2. That's what we want to find out. Okay, times 100 centimeter cube, which we converted into 10 times to the power of minus 1 decimeter cube. So it means here, in other words, we can say molarity of Fa2 equals to 2 times 10 to the power of minus 2 divided by 10 to the power of minus 1, which means that 0.2 mole decimeter to the power of minus 3. That's the molarity of Fa2. Then, what is the mole of Fa2 used in titration? Now, it means here we have to refer to the volume that is used. Be careful, the volume that is used in titration is different from the volume of the dilution, of the before and after dilution. Be careful. Once you put the wrong data, then the whole calculation will be wrong. Yeah. So it means here 25 milliliter is the volume that is used for Fa2 in titration. So we convert it into decimeter cube, which means that 25, I'll just put it 2.5 times 10 to the power of minus 2 decimeter cube. Okay, and then multiplied by the molarity of the of the Fa2, which is times, I'll just put it like this, 2 times 10 to the power of minus 1 mole decimeter to the power of minus 3. So it's easy for us to calculate. So it means here 2.5 times 2 equals to 5. Yeah, so it means that we can say here mole. So it means here 5 times 10 to the power of minus 3 mole. That is the mole of Fa2. Okay, next then. Write the balanced chemical equation of the neutralization of diluted sulfuric acid, Fa2, and diluted NaOH, Fa4. So in this case, NaOH, aqueous, plus sulfuric acid aqueous equals to sodium sulfate aqueous plus water liquid. And then here we balance the number of atom for sodium and number of atom for the hydrogen. Okay, that's the first. Yeah, I hope that it is clear by now. So right now we'll continue to the next one. I'll erase this. Okay. And then we'll continue to the next one, which is the next question is, okay, what is the mole of Fa4 used in titration? We have to actually refer to the previous answer. Okay, I hope I still remember. Okay, wait, yeah. Let me make it bigger first. Okay, what is the mole of Fa4 used in titration? If we remember just now for Fa4, okay, yeah. Wait, just now, okay, here. Okay, for Fa4, just now, after we got the balance equation, we know that Fa4 is sodium hydroxide, and the mole of sodium hydroxide is twice of the mole of the sulfuric acid. And just now we got the mole of sulfuric acid. How many? Just 2.5. 5 times 10 to the power of minus 3. Yeah, 5 times 10 to the power of minus 3 mole. Okay, that's the mole of Fa2, right? So in that case, then the way we find this is, so the mole of Fa4, which is the mole of sodium hydroxide diluted, okay, equals to 2 times the mole of sulfuric acid diluted, which is, okay, which is 2 times 5 times 10 to the power of minus 3 mole. Okay, or we can say 10 times 10 to the power of minus 3, 10 times 10 to the power of minus 3, or we can say 1 times 10 to the power of minus 2 mole. Yep, okay. Then what is the volume of Fa4 used in titration? The mole of Fa4, or this is the mole of Fa4 diluted, is the, sorry, NaOH diluted is the Fa4. So the mole of the, oh, the volume, what is the volume? Yeah, what is the volume? Just now we got also the molarity of Fa4, because this one Fa4 is 2 mole per decimeter cube the diluted 10 times. It means that the molarity of Fa4 is 0.2, or 2 times 10 to the power of minus 1. Okay, and then what's the connection? So it means here the volume, because molarity equals to mole per volume, right? So it means that when we want to find out about volume equals to mole per molarity. So it means here the volume of Fa4 used is, we know the mole just now, which is 1 times 10 to the power of minus 2 mole. Yep, divided by the molarity is 2 times 10 to the power of minus 1 mole, decimeter to the power of minus 3. So the mole is cancelled. 1 divided by 2 is half. And then here we have half times half means 0.5, yeah, 0.5 times 10 to the power of minus 1, or we can say 5 times 10 to the power of minus 2, yeah, 5 times 10 to the power of minus 2 decimeter cube. Be careful. And then when we want to change it into centimeter cube, it means that it's 50 centimeter cube, okay? And then initial color, because the first thing that we use is sulfuric acid. So the color, the first color is yellow. Okay, and then final color, at the end, we have hydroxide, sodium hydroxide, which is base. So you can say either blue, it means that you have like 1 drop of extra sodium hydroxide, or if you can do it exactly, which is usually rare, you can also put here green. Okay. Okay, I think that's all. Another example for dilution and titration. Keep on learning. Bye-bye.